that control equipment operations via network connections. So with the emergence of new advancement technologies such as cloud, mobile computing, fog computing, and Internet of Things, the internet has become and will be the more ubiquitous. So this ubiquitous makes our lives more easier. So it creates unprecedented challenges for cybersecurity. So nowadays, it's not a day goes by without a new story on the topic of security, either a security incident or an information leakage or an abuse of an emerging technologies such as autonomous or hackings software that we have been using for years. So why can't these cyber attacks be stopped? So the answer is very complicated. So partially because of the dependency on the legacy systems, human errors are simply not paying attention to security aspects. And in addition, an increasing complex threat landscape makes a traditional cybersecurity mechanisms ineffective. So what is the role of big data in this cybersecurity? So the big data is further making mission worse because the many sources we have been generating the huge volumes, tons of data, enormous amount of data daily. So that's why the situation becomes more worse. And the big data presents additional challenges to the cybersecurity. And if you take an example of IoT, like Internet of Things, and as per the predictions of the Cisco, by 2050, there will be 50 billion devices are connected through IoT. So these will generate the 50 billion devices would generate a huge amount of data. It's more than 400 zettabytes of data every year nowadays. So self-driving cars is another source that creates a significantly more data for people. Next, the app driver will churn out of around 4,000 GB of data per day. That is just, so not per day, it is just for 1 hour of driving a day. So big data analytics as an emerging analytical technology offers the ability to collect, store, process, and visualize big data. So therefore, applying analytics in cybersecurity becomes critical and a new trend. So by exploiting the data from the new network computers, analysts can discover useful information from data using their analytic techniques and processes. So here we are going to discuss, that is, I'm going to give an introduction to the big data analytics and mainly the power of big data analytics and cybersecurity. And let us start with the introduction of big data. As I said, I'll give a brief introduction about the big data. Here we'll see what is big data, why the big data is so complex, and what are the differences between traditional analytics and big data analytics. What are the different types of data, and what are the characteristics here we will be going to discuss. So what is a big data? I think most of you might have heard about the definition. That is, describe the big data in terms of its characters like 3 V's, 4 V's, 5, etc. So, any definitions, if you Google the definition of big data, you will find many definitions. Here, among those, one definition, that is, it is a big term applied to data sets whose size or type is beyond the of traditional relational databases, that is in terms of capturing, managing, and processing. As formally defined by the Gartner, big data is a high volume, high velocity, and a high variety information assets demand cost effective innovative information processing that enable enhanced insight, decision making, and process automation. So the characteristics of big data are often referred to as three V's, like volume, velocity, and variety. So the big data analytics refers to the use of advanced analytics techniques on big data to uncover the hidden patterns. And if you look at this, why I'm saying this, big data analytics is complex. And by seeing this image, again, the elephant, there are 6 people here, and one person, that is by touching this part of the elephant, and he was saying that it's a fan. And another person here, by touching this portion, and he was saying that it's a wall. And another person by touching the here, and he's saying it looks like a rope. Like that, there are among 6 persons are having 6 different opinions, perception. So what do you mean by this? Can anyone guess the meaning of this image? Would anyone? Okay, so because the big data is complex, as we discussed, it has characteristics, volume, velocity, and variety mainly. So one person or a team with one person cannot cannot come up with more meaningful insights. We cannot interpret the data. So we have to, there should be a significant number of analysts, and they should get the data from different parts, and they should integrate that information and to give a meaningful insights to the businesses. And one more example you can see here, it's not example, these are the statistics. And if you want, you can also Google NetLife statistics, and you will be able to see the volume of data and the velocity and variety, the size and the speed at which the data are being generated from different sources, and what are different formats of data being generated by different sources. And here you can see this, what happens in a minute in 2022. Like here you can see that people reading the Yelp reviews, that is around 4K, apps downloaded 174K from the Google Play Store, the text sent 16.2 million, for text being sent in a minute, 231 million emails was sent in a minute, songs streamed in the US, that is 694 millions, and the people shopping online for in a minute, 6 million people was shopping, and 5.9 millions of Google searches per a minute. These are all the, you can just to understand how big the data is nowadays. Everyone should understand the big data characteristics. So big data analytics refers to the use of advanced analytical techniques on big data to uncover the hidden patterns that those are previously unknown correlations, market trends, customer preferences, and other useful information. And these advanced analytical techniques includes the text analytics, machine learning, predictive analytics, data statistics, natural language processing, and so on. So analyzing big data allows the analysts, researchers, and business users to make better and faster decisions using data that was previously inaccessible or usable. That means that is in a different format. We cannot directly apply any data mining or machine learning or any other techniques. And what is the difference between the traditional analytics and big data analytics? Why we are using the term called as a big data analytics? Earlier, uh, we used to call like the data or data mining. Okay, and we use some storage that is for storing historical data like data warehouses. So, what is the real difference between the traditional analytics and the big data analytics? So traditional data warehouse is mainly like, suppose if you look at this data warehouse, it mainly focuses more on a structured data. Most of the data, whatever the data being stored into the data warehouse is uh, been undergone the process of extraction, transformation, and loading. So that's why most of the data, that is because it has a unique schema, that means a structure. So that's why the data warehouse mainly focus more on structured data, that is mostly rely on the relational databases. And it may not be able to handle the semi-structured and unstructured data well. Whereas big data analytics offers a key advantages of processing unstructured data using a non-relational database. Further, data warehouses may not be able to handle the processing demands posed by sets of big data that need to be updated frequently or continuously. So big data analytics is able to deal with them well by applying a distributed storage in memory processing. That we will discuss in a couple of minutes. And we are going to compare this, that is, should understand the differences between traditional analytics and big data analytics in terms of distributed storage, support for unstructured data, and the past processing, etc. So what do you mean by distributed storage? Because that is the advantage with the big data analytics. So volume, as we discussed, there are three characters mainly. There are many other characters also, focus mainly on three characters: volume, velocity, and variety. So volume is the key of Gartner's definition of big data. One key feature of big data is that it usually relies on distributed storage systems. Because the data is so massive, that is that size would be petabytes or even higher than the petabytes. Like to check this, as CERN, largest hydrogen collider, that generates 150 petabytes of data per year. So that's why they are having their own data center. So that's why, because if that petabytes of data we cannot store in a single node, cannot process with a single node. So big data also requires the storage system to scale up with the future growth. Scaling down, that is the vertical scaling and horizontal scaling. Like suppose if you are using a machine does not support, the RAM does not support any job, then you would increase by adding extra memory. And that is one kind of scaling. And that is called as, and another kind is like we can use another machine so that we combine the performance of those two machines. So hyperscale in environments, those are used by the major big data companies, Google, Facebook, and Apple. All these companies for the big data storage requirements by constructing from a vast number of commodity servers with a dynamic storage, DAS. So many big data practitioners build their hyperscale computing environments using the Hadoop clusters. That was initiated by Google. It is Apache Hadoop is open source framework that is freely available because it is under the GPL license. And it is used for distributed storage and distributed processing of very large data sets on computer clusters built from commodity hardware. There are two key components in Hadoop, mainly HDFS, Hadoop Distributed File System. It is a distributed file system that stores the data across multiple nodes. And another one is MapReduce, a programming model that processes data in parallel across multiple nodes. So under this, map queries are split and distributed across the parallel nodes. Like suppose I'll give one simple example. If you're not clear of what MapReduce and Hadoop HDFS works, how. Like suppose if I have a 10-page article, 10 pages article, the task is to count the number of words, the frequency of word in that article. Like it has 10 pages. If I give this task to one person, he would take, let us say, 10 minutes. So each page would take 1 minute of time. So to complete the given task, 10 minutes. Okay. So instead of giving this entire article, if I split this article and give each page to one person, then the same task, that is counting, word counting, would be done in a minute. Is it clear, all of you? Are you getting me? Can you please confirm?
Sir, it's audible, sir.
Okay, thank you.
Right.
Yeah, just I want to check in the middle.
Okay, sir.
Okay, so like this simple basic example, like 10-page article, if it give it to one person, he would take 10 minutes to count the words and their frequency. But the same task, if I give each page to one person, then this task would be done in 1 minute. That is the way this HDFS, distributed computer processing, works. Because the traditional databases are, you can take a data warehouse, does not support. It needs to store the entire data in one location. We cannot split the data set. Like suppose if we have 1 gigabyte of data, if your machine does not support, so if your machine does not have a storage, then that need to be splitted and distributed among the different nodes. But that is not possible with the traditional analytics. So that is with the distributed file system. So that is one basic example, and that is any layman can understand this. So this approach, that is MapReduce, that takes the advantage of the data locality. That means nodes manipulate the data they have access to, and to allow the data sets to be processed faster and more efficiently than it would be in a conventional supercomputer architecture. And another difference is that is whether this supports traditional analytics or big data analytics supports for unstructured. And if you look at, if you search the amount of unstructured data being generated, like suppose, as I said, by 2050, around there are 400 gigabytes of data would be generated. That is from IoT devices. That 400 gigabytes of data, what is the how much portion of data is structured and unstructured? And even if you search the reports of IDC, International Digital Corporation reports, and the percentage of unstructured data available, that is more than 80%. Whatever the data available nowadays, that so more than 80% of data is unstructured data. Earlier, that is olden days, we used to handle only the structured data. But nowadays, 80% of the data is unstructured. We cannot directly apply any algorithm. So we need to pre-process. That's why the data science projects, the team would spend around 80-72% of time in pre-processing the data and accelerated data analysis. So unstructured data is a head, as we just now discussed about how much data being generated, what are different varieties of data being generated in a minute. There are different formats, like the format, the text, document, image, video, and etc. You can also see some sources that are generating the unstructured data. For example, email and other forms of electronic communication. Next, web-based content, including the click streams. Like we are using the internet, and by using any browser, we are opening the different websites, we are accessing the different content, etc. Whatever the activity we done, that I recorded as a log, and that is called as a click streams. That means, suppose if you open a website and you may click on a particular link or a hyperlink on an image or a text or a box, anything, and everything would be recorded. And that is the data set is called as a click stream. And the analytics is performed using this click stream data called as click stream analytics. So that the vendors will understand, like suppose if you want to purchase a product from Amazon, and you will open the Amazon website and you will browse for the required product. There you will apply the filter, there you check for price, there you will check for the color, you will check for the different measurements, etc. And there you will check reviews, ratings, etc. Huge information you will see before you proceed to purchase a product. So whatever the information you accessed, whatever the clicks, whatever the hyperlinks you clicked, everything would be recorded. So based on that, they will understand the behavior of the customers. Okay, what they are looking for. Next, digitized audio and video, and that is another complex format need to be handled. Next, machine-generated data, RFID, GPS, sensor-generated data, log files, and then the thing is Internet of Things. These are the different sources where we get unstructured data. So even that unstructured, the portion of unstructured data is more than 90% of all that data that was created next decade, that will be created next decade. So these unstructured data analytics can reveal the important interrelationships that we are previously difficult or impossible to determine. However, the relational database and technologies derived from it, example, data warehouse cannot manage unstructured data and semi-structured data well at large scale because the data lacks a predefined schema. So to handle the variety and complexity of unstructured data, databases are shifting from relation to non-relational. So that's the reason we are studying the NoSQL databases. So these NoSQL databases are broadly used in big data practice because they support dynamic schema design. So no need to predefine the schema, but you can dynamically design the schema. So because that offers the potential for increased flexibility, scalability, and the customization that is compared to the relational databases. And these are designed with the big data needs in mind and usually support the distributed processing very well. Next, another aspect that is fast data processing. And so far we discussed about the volume mainly. We are focusing volume and the variety. That is a different formats of data. Next, another aspect you see that is how fast the data being processing. Because if you look at, because big data is not just a big, it is also fast, speed, velocity. So big data is sometimes created by a large constant streams. Streams means it's continuously arriving. It generates the data continuously, and there is no control on it. So, and we need to process the data as fast as possible. Then we have to discard it because we are not going to store this streaming data. We cannot accommodate this streaming data. So that's why on fly, we have to analyze this data. So streaming data includes a wide variety of data, like such click stream as we just now discussed, the financial data, transaction data, log files generated by mobiles or web applications, and sensor data from Internet of Things, that is IoT devices, in-link air activity from the connected devices. So the benefit of big data analytics is limited if it cannot act on data as it arrives. Because suppose if you take just one second. So suppose if the data is arriving like this, I could not write. Okay, let me write with hand. Okay, so these are the data. Let us say these are the data items which are continuously arriving. Okay. Let us say a window size is this one. This is a window size. Okay. So that means, let us say this window average number of transactions. Let us say this is a transactional data stream, and the average number like 1,000. Let us say 1,000 transactions. Because here the data streams will not generate the data the constant rate. That rate may change at any time. So at this particular time, let us say if the window size is 1 minute window, this is a 1 minute window, 1 minute window, 1 minute window, within 1 minute, will be able to process 1,000 records. If the speed is high, then like let us say there are 2,000 transactions per a minute, but our algorithm or model machine could process only 1,000 records, then we should discard, we will miss 1,000 records. So whatever the insights you derived out of it, those cannot be accurate. So that is the another challenge, because the data speed is very high, the fast processing is required. So this streaming data needs to be processed sequentially and incrementally on a record by record basis over the sliding time windows, and used for a wide variety of applications, including the correlations, aggregations, filtering, sampling, etc. So here the big data technology unlocks the value in fast data processing with the new tools and methodologies. For example, there are some tools that is in Hadoop ecosystem component like a Storm, Apache Kafka. These are the two popular stream processing systems. So originally developed by uh, these processing systems were developed by the engineering team at Twitter, and the Storm can reliably process unbounded streams of data at rates of millions of messages per second. And Kafka, developed by the engineering team at LinkedIn, it is a high throughput distributed message queuing system. Both the streaming systems address the need of delivering the fast data. So neither traditional relational databases nor the NoSQL databases are capable enough to process the fast data. So traditional relational databases is limited in performance, and the NoSQL systems lack support for safe online transactions. But in-memory new SQL solutions can satisfy the needs for both performance and transaction complexity, as we just discussed. So new SQL is a class of modern relational database management system that seek to provide the same scalable performance of NoSQL systems for online transaction processing. That is called as a OLTP. And also performs the workloads while still maintaining the atomicity, consistency, durability. So some new SQL systems are built with shared nothing clusters. Workload is distributed among the cluster nodes for performance. So data is replicated among the cluster nodes for safety and availability. New nodes can be transparently added to the cluster. That is in order to increase the workloads. And the new SQL systems provides both the high performance and scalability in online transaction processes. So there are many big data technologies and products available in the market. And the whole big data ecosystem can be divided from this. You can see here the big data landscape 2016. And here this divided it mainly into the three categories: infrastructure, analytics, and applications. Yeah, this is infrastructure category, application, and analytics category, and the applications. Let us see one by one what comes under this infrastructure, analytics, and applications. Infrastructure, that is the fundamental part of big data technology. So it stores, processes, and sometimes analyzes the data. So as we discussed earlier, the big data infrastructure is capable of handling both structured and unstructured data at large volumes and fast speed. It supports vast variety of data and makes it possible to run applications on systems with thousands of nodes. So those are potentially involving thousands of terabytes of data. So if you look at the key infrastructural technologies, including the Hadoop, NoSQL, and massively parallel processing databases, MPA. Next, analytics. So these analytics tools are designed with data analysis capabilities. That is on big data infrastructure. Like there are some tools you can ingest the data into this analytics, and you can send the data from the external sources to the HDFS, and you can also store the data from HDFS to external sources. So big data analytics tools can be classified into the following subcategories. So like analytics platforms. These analytics platforms integrate and analyze the data to uncover the new insights, and they help the companies make a better informed decisions. So there is a particular focus on this field on latency and delivering insights to end users in the timeliest manner possible. The next one is analytics category, that is analytics platforms. Sorry, analytics platforms. And the next one is visualization platforms. And these visualization platforms are specifically designed, as the name might suggest, for visualizing the data. That is taking the raw data and presenting it in a complex, multi-dimensional visual formats to illuminate the information. Next one is a business intelligence. So this mainly used for integrating and analyzing the data specifically for businesses. So BI platforms analyze data from multiple sources to deliver the services such as business intelligence reports, dashboards, like mainly using a Tableau, Power BI, and even Excel, MS Access. You can build the dashboards, and by using other programming languages, Python and R, you could build the visualizations. And another very, very important thing is machine learning. It also falls under this category, but it's dissimilar to the others. Whereas analytics platforms input processed data, analytics platforms mainly will give input as a processed data, and the output analytics or dashboards or visualizations to end users. But in case of machine learning, the input of machine learning is data where the algorithm learns from, and the output depends on the use case. And if you look at the famous example of that is IBM supercomputer Watson, which has learned to scan the vast amounts of information to find specific answers and can comb through the 200 million pages of structured and unstructured data in minutes. Next, application category. The big data applications are built on big data infrastructure and analytical tools to deliver optimized insights to end users by analyzing business-specific data. So, for example, one type of application is to analyze the customer online behavior for retail companies. Like suppose as I said, Amazon. If you want to purchase a product and you would browse, let us say if you are browsing Amazon, there you will apply the different functionalities and to search for the required product. So they will analyze the behavior of that particular customers and to have the effective marketing campaigns and increase the customer retention, mainly whether the customers are happy about their products or not, like by looking at their reviews, what they have expressed, what their experiences. And another need for big data analytics, cyber security. Let us discuss. While big data analytics has been continuously studied and applied into different business sectors, cyber security at the same time is experiencing the big data challenge due to the rapidly growing complexity of networks like virtualization, smart devices, wireless connections, IoT, etc., and increasingly sophisticated threats like malware, multi-stage APTs, etc. It has been commonly delivered that the cybersecurity is one of the top critical areas that big data can be a barrier to understand the true threat landscape. So to understand that, we should discuss some limitations of traditional security mechanisms. So the changing and increasing complex threat landscape makes traditional cybersecurity mechanisms ineffective in protecting organizations and ensuring the continuity of their business in digital and connected context. So many traditional security approaches, such as the network level, host level, firewalls, have typically focused on preventing attacks. So they take the perimeter-based defense techniques mimicking the physical security approaches, which focus primarily on preventing access from outside on defense around the perimeter. So more defense layers can be added around the most valuable assets in the network in order to implement defense in-depth strategy. However, as attacks becomes more advanced and sophisticated, organizations can no longer assume that they are exposed to the external threats only, nor can they assume that their defense layers can effectively prevent, prevent all potential intrusions. So cyber defense efforts need to shift focus from prevention to attack detection and mitigation. So traditional prevention-based security approaches would then constitute only one piece of a much broader security strategy that includes detection methods and potentially automated incident response and recovery processes. So traditional intrusion and malware detection solutions mainly rely on known signatures and patterns. That's why, so we need, suppose if you are using any antivirus license version, and we need to enable the auto download option, auto upgrade option, so that it would download the new signatures from the vendor, so that it could able to detect the new viruses, malwares. So the more advanced detection techniques are seeking to effectively distinguish normal and abnormal situation behavior and activities either at the network traffic level or at the host level or at the user behavior level. So abnormal behaviors can further be used as the indicators of malicious activities. For detecting the never before seen attacks. And next one is the evolving threat landscape that requires a new security approaches. These new technologies such as virtualization technologies, smartphones, IoT devices, and their accelerated pace of change are driving major security challenges for organizations. So furthermore, the expanded attack surface and the increasingly sophisticated threat landscape pose the most significant challenges to the traditional cybersecurity tools. For example, the rapid growth of IoT, mainly Internet of Things, connects a huge number of vulnerable devices to the Internet. Therefore, exponentially expands the attacks, such as attacks surface for the hackers. And you could also see the IDC study of worldwide IoT market, how many devices. As I said, by 2050, the 50 billion devices would be connected through internet. So a recent study was released by the HP that showed that 70% of IoT devices contain a serious vulnerabilities. So the scale of IoT and the expanded attack surface makes the traditional network-based security controls unmanageable, and those are unable to secure communications generated by the connected devices. So the convergence of information technology and operations technology driven by the IoT further complicates the task of network administrators because the huge number of devices will be connected. So another example, this advanced persistent threat has become a serious threat to the business, but the traditional detection methods are not effective defending against it. So this APT has become characterized by advanced in terms of using sophisticated malware to explore system vulnerabilities and being persistent in terms of using external command and control systems to continuously monitor and extract data from a specific target. So traditional security is not effective on APT because the APT often use the zero vulnerability to compromise the target. The traditional signature-based defense does not work on those attacks. The malware used by the APTs usually initiate the communication to the command and control server from inside, which makes the perimeter-based defense ineffective. And the APT communications are often encrypted using the SSL tunnels, which makes traditional IDS or a firewall unable to inspect its contents. So APT attacks usually hide the network for a long time and operate in a stealth mode. So traditional security, that is, which lacks the ability to retain and correlate events from different sources over the long period, is not capable enough to detect those attacks. So in short, new cybersecurity challenges make the traditional security mechanisms less effective in many cases. That is especially when big data is involved. So big data analytics offers new opportunities to the cybersecurity. Let us see. So this big data analytics offers the opportunity to collect, store, and process enormous cybersecurity data because we could use machine learning or AI or deep learning techniques to analyze the huge volumes of data. That means that security analytics is no longer limited to analyzing the alerts and logs generated by the firewalls, proxy servers, IDs, and web application firewalls. So security analysts can analyze a range of new data sets in a long time period, gives them more visibility into what's happening on their network. So they can do the more and more analysis, so that they can see what is happening on their network. For example, they can analyze network flows and full packet captures for the network traffic monitoring. And they can use communication data, that is including email, voice, and social networking activities. So user identity context data, as well as web application logs and file access logs for advanced user behavior analytics. So furthermore, business processes data, threat intelligence, and the configuration information of the assets on the network can be used together for risk assessments. So malware information and the external threat feeds, that is including the backlist and watchlist, GRP data, and the system audit trails may help with the cyber investigations. So the aggregation and correlation of these various types of data provides more context so that you can integrate that information as we discussed in the beginning. The aggregation and correlation of these various types of data provides more context information that helps broaden the situational awareness and minimize the risk and improve the incident response. So new use cases are enabled data's capability to perform a comprehensive analysis with the distributed processing and with affordable storage and computational resources. Then how do you apply the big data analytics in cybersecurity? Let us see the different category of solutions, how big data we applied in cybersecurity, like the category of current solutions. The existing efforts of applying the big data analytics into cybersecurity can be grouped mainly into three categories. The first one is enhance the accuracy and intelligence of existing security systems. That is, security analytics solutions in this category use ready-to-use analytics to make existing systems more efficient and less noisy, so that the most energies events are highlighted and prioritized in queues while alert volume is reduced. So the big data aspect of this solution domain comes in a more advanced stage of deployment, where data and alerts from separate systems, example, data leaks prevention, SIEM identities, and access management, or endpoint protection platforms are enriched with the contextual information, combined and correlated using CAN analytics. So this gives an enterprise a more intelligent and holistic view of our security events in its organizations. The second one is combined data and coding activities using the custom or ad hoc analytics. Like enterprises use big data analytics solutions or services to integrate the internal and external data. Okay. So sometimes they may rely on the external data, and they may integrate the external and the internal data so that they'll get more meaningful information. Like the external data could be that is structured as well as unstructured. So they will apply their own customized or ad hoc analytics against these big data sets to find security or fraud events. And the third one is the external cybersecurity threat and fraud intelligence. That is, the security analytics solutions apply big data analytics to external data on threats and bad actors, and in some cases combine the external data with other relevant sources like supply chain vendors, ranking, and social media. And most of the vendors of these solutions also create and support communities of interest where the threat intelligence and analytics are shared across customers. So vendors in this category actively find malicious activities and threats from the internet. So turn this information into actionable data such as IP addresses of known bad sector service servers, malware signatures, and share with their customers. So these are the different ways we could apply the big data analytics in cybersecurity. Just 1 second. And another very, very important thing is the architecture. What is a big data security analytics architecture? You can see the architecture of big data security analytics. And it has 5 core components like services, apps, data presentation, integration, data access, data consumption, data storage. Let us see one by one. I'll give a brief about what each category. Storage platform, that is store the data. That is it supports a lot log data retention, and batch processing jobs. There are few offerings in the market that skip this layer and using a single NoSQL database to support all the data retention, investigation, access, and but considering all the available open source applications in the Hadoop ecosystem or a Hadoop-based platform still gives a more economical, flexible data solutions for the large data sets. And the data access layer that is with a fast query response performs the support, investigation queries, and drill down because the data access inside the Hadoop is batch based. So this layer is necessary to support the analytics investigations. And this layer can either be a standalone massive parallel database such as a Vertica, Greenplum, and at the NoSQL database like Solar, Cassandra, and Elasticsearch, with our integrated offerings such as Impala and Spark directly from the popular Hadoop distributions. And the next one is data consumption layer. This data consumption layer to receive the data from various sources. Actually, it would receive the data from data sources. That means we can push the data into the HDFS or we can extract the data from the HDFS into the other sources. That is either from the log sources directly or through the log concentrators such as syslogs, ng, the flow connectors or SIME tools. Next, integration layer that is composed of collection of APIs. That with the other security operational tools such as the STEM, EGRC, and the ticketing system. At the same time, a good API layer that not only supports the integration with other solutions, but also provides flexibility and the clear design to internal analytical modules. So we expect that the amount of requirements and complexity of analytics will have a tremendous future. So API-based, nowadays we've been using this API-based analytics. So we need to rely on API-based analytics as a service architecture in the future. So in addition to the above the 4 parts, an operational data presentation layer that is to allow users to consume the analytical results. Because suppose if a company want to perform the business, they want the reports. And the developer would design these reports with the help of reporting tools. And they will give access to them so that the end user, that is mostly they are from MBA background, they can directly access. They no need to have any technical background, or they no need to learn any query language to get the required data. So one or more visualization platforms we need to visualize both the high dimensional data and the relational graphs. So security analytics services and applications can be built on the top of integration layer and the data presentation layer. So that is depending on if the visualization is necessary to the user applications. And if you see the different use cases, so far what we have discussed, that is completely a theory. It may not be possible to show or explain each and every concept in detail in 2 hours. I kept the 2 use cases so that if you're not clear till now, the role, what is the power of big data in cyber security, with this you will get some clarity. Here, mainly what is the use case. So let us start with a use case is a set of solutions, right, to solve a specific business challenge. It is mainly important to understand what the challenge or a requirement comes first, and then we engineer the solution. And when talking about cybersecurity analytics use cases, a common mistake is to start with the available data and think about what can be done with that data. Instead, an organization should start with the problems, threats before looking at the data and then design with available data. So we are going to describe the three use cases for big data security solutions, mainly the data retention or access, the context enrichment, and anomaly detection. The first two use cases are more straightforward and relatively easy to implement and measure. So we are going to spend some time discussing about this anomaly detection use case. But in practice, the first two more probably be generated by the better return on investment for the most organizations. So by the nature that the number one requirement a big data solution fulfills is the data availability. That is the number one requirement. So Hadoop-based architectures enables the storage of large volume of data with a high availability. Because we are splitting the data into blocks and storing across the nodes in Hadoop cluster. If a node wants to access the data, so then that will be available with that. So mapping into security operations, a basic requirement that analysts need to access the security data and information for their daily operations. So this includes that is providing managed access to the raw logs and extracted metadata. Metadata means it's data about data, and advanced data filtering and access and visualization interfaces. So there are many factors that we need to consider requirements. So keep in mind that the Hadoop system does not provide the best query response time. There are many other database systems that can be leveraged to provide the faster query performance and serve as a data cache for analysts. However, there is an additional cost, that is a scalability concerns and sometimes accuracy trade-offs to be considered with these systems. So the best way to approach this design is to start with the bare minimum requirements on data access and retention. So that is, what is a minimum retention period for various types of data? And what is a minimum requirement on the query performance? How complex will the queries be? So from there, we will ask further questions like what is preferred for various that is in the fast access flag. I think somebody. Muted. Hello. Okay. Participants, are you with me or not? Can you please confirm is my voice is loud and clear? You are all able to see my screen?
Yes, sir. Yes, sir. We are able to see your screen. Yes,
okay, it's completely theory, but yeah, that's right. Okay, so let us see what is one by one like here. The data retentions, access, the context enrichment, etc. So if you look at this context enrichment, big data platform processes so many different kinds of data from vast number of sources, as we keep on discussing. The big data being generated from different sources. So it's of great value to use the heterogeneous data to enrich each other, provide additional context. So here the goal of such enrichment is to pre-load the security relevant data automatically, so that analysts do not need to check those enriching data sources manually. So like enriching the IP-based data, that is firewall logs, net flows, and enriching the host-based data with the user identities from IAM, and enriching account-based data with human resource context, enriching proxy logs with metadata of emails containing the links accessed, enriching internal network flow data with the processes, access information from endpoint data, etc. So practitioners should note that the key performance constraint of data enrichment solution is the underlying data parsing and linking jobs. Because this type of solution involves the close interaction with the human analytics, and it is ideal to have a low latency here. And another important thing is anomaly detection. So anomaly detection, this is another very, very important technique in data mining, and even other machine learning. It's a technology that is to detect malicious behavior by comparing the current activities with the learned normal profiles of the activities and entities. So which can be user accounts, hosts, networks, or applications. As an intrusion detection technology, anomaly detection has been proposed and studied for over 2 decades, but it is still notorious for its low accuracy. Specifically, although it is capable of detecting some novel attacks, it tends to give access to amount of false positives, which tends the technology impractical. Means it's a misclassification. So now the enterprises are revisiting the idea of implementing anomaly detection technologies as part of their security monitoring measures for 2 reasons. The one is the threat of advanced persistent attacks has become significant to many organizations. Second, advance in big data technology enables organizations to profile entity behaviors over the large volumes of data, long periods of data, and with high dimensions in modeling behavior. So this can greatly improve the accuracy of anomaly detection. There are many other possibilities when it comes to the anomaly detection use cases. So based on the origin and the target of threats, anomaly detection use cases can be roughly grouped into these following categories. Like external access anomalies, browsing activity monitoring example, and the remote access anomalies, VPN access monitoring, the lateral movement anomalies, endpoint anomalies, external facing data movement anomalies. These are the different categories of anomalies. How the anomaly detection would work. So an actual use case may be a combination of cases. For example, a model to build there is a model to build to monitor the Bitcoining behaviors with users' web browsing activities may be combined with endpoint anomalies together to form a malware monitoring use case. So to establish those cases, data scientists need to first work with the business owners, because they should understand to identify the control gaps where analytics needs to fill in. Then work with the engineers that is to identify the available data to build the models. So when considering the available data sets, one should always keep in mind that there are some great resources publicly available on the internet, like the geo IP data that can be used to track the remote access locations, who is info, and the various other, that is various threat intelligence data that can be cross-referenced to evaluate a remote site's readability. So here we see some the key components of building anomaly detection use cases. So let us take one use case, that is VPN access monitoring. Here the scenario is like an unauthorized party stole is given a user's credential to log on to the company VPN remotely to get into company's internal network. So the two users sharing the same VPN credentials, which violates the company's remote access policy. That is the threat scenario. Okay, I'm just repeating this. The scenario: an unauthorized party stole is given a user's credential to log on to company VPN remotely to get into company's internal network. The two users sharing the same VPN credentials, which violates the company's remote access policy. This is a threat scenario. Let's try to understand this use case. And what are the control gaps? So currently the only control over the VPNs is user's credentials. So once a user passes the authentication, there is no additional control, right? We just pass the credentials, no additional control. And next, the data source point of view, the VPN logs users office badging data and geo IP data it has. Then the data exploration, like a VPN logs contain the timestamps, user ID, external source IP address, and the DHCP address assigned to the VPN connection, etc. Next, badging data contains the timestamps, employee ID, and the action. GeoIP data is a free max-min data set. For more accuracy, we can also use a commercial data set. Features, that is external IP addresses, are converted into the geolocations with the GeoIP data. The VPN user IDs are mapped onto the actual employees' IDs. So the detection model, how the detection model would work. It measures the distance between users' last two accesses. Like suppose, let us take another example here. Suppose if you have done a purchase, if you made a transaction for, let us say, some amount by using your credit card, then within a very short time, one more transaction was done in another country, and that transaction would be suspected, and that the system will not allow to complete that transaction. Okay, so similarly here in this scenario, that is a remote VPN access monitoring, the model measure the distance between users' last two accesses. That is example badge of his location and VPN logon between the two VPN logons. Next, measure the elapsed time between those events. Then derive the minimum travel speed of the user between the two accesses. Then compared to that, a pre-established max travel speed threshold, they would set a threshold value like 500, 400 miles per hour and see if it exceeds that threshold. Then additional improvements what are the additional improvements we could perform to the model? The inherent errors with the geo-IP data, like errors usually happen with large nationwide ISPs, especially with mobile connections. Please check in the wide list from a training session usually minimizes such errors. So for corporations with the travel verticals, which provides users business travel agendas, such data can provide additional detection opportunities or accuracies. So that is about the like a little a simple use case to understand the role of data here, the role of models, etc. Next use case, abnormal sensitive data gathering. And let us first understand the threat scenario. A malicious insider or a compromised account gathers sensitive data in preparation for the exploit operations. The control gaps. The enterprise does have a DLP solution deployed on endpoints and in the network. The coverage of the DLP is not complete. The most significant gaps are that the host DLP does not create the system level dependencies and hence has no control over the transformed files. Next, the network DLP is only deployed over the email, HTTP, and FTP channels. The inspection is not adequate for other protocols such as SSL or SFTP. Hence, behavior-based analytical model would be a great mitigation control here. And the data sources, SQL audit log for the customer info, DB, internal net flows, inventory of a file, chase containing sensitive data. And what kind of data exploration could be done? A SQL audit log contains a lot of noise that provides the great details, the queries, and the number of records written. Internal net flows shows the source or destination IP addresses, ports, and upload or the download volumes. Next, file share inventory is updated on a daily basis by a custom-built data scanner. It identifies the host name, IP address, and share the name of the file, shares the sensitivity of the data content, and the level of security controls over the share. And if you look at the features, the daily sensitive, that is potentially sensitive, the data download volume, that is by accumulating the downloaded volume through the port, that is 445 for Windows file share, and the 1433 SQL file shares or DBS hosting sensitive data. The number of sensitive data records downloaded, that is identified directly from the SQL audit logs. And if you look at the model, users daily sensitive data downloaded volume and detect significant spikes with the time series model. There we could apply the time series model. And additional improvements we done to the model, that is identifying each user's peers based on their team or a group supervisor data can help identify the context of sensitive data usage of the peer groups, so that that can be used to improve the detection accuracy. And it can be correlated with the data exfiltration anomalies such as suspicious uploads to file sharing sites or uncategorized sites. And it can be correlated with the malware anomalies such as C2 decoining behaviors. And it can also be correlated with remote access anomalies as well. So just I'll give a 5 minutes break and we'll back. And please be connected. I'll be back in just a not more than 5 minutes. Then we'll discuss the rest, mainly the challenges to the big data analytics for cybersecurity. Yeah, welcome back. Am I audible? Can anyone confirm?
Yes, sir.
Okay, we are going to close. There is a small concept, and that is a very, very important concept. Let me. Can you please confirm is my screen is visible or not? Can anyone?
Sir, it was not yet visible, sir. Have you
Now,
said?
is it visible, ma'am?
No, sir.
Okay, just one second. Is it visible?
Yeah, sir. Now okay.
Okay, 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 okay. Yeah. So this is a very, very important concept. So that I think if you're still not clear of what is correlation between big data and cyber security, you will get some little clarity with this concept. Or let's check what are the challenges to the big data analytics for cyber security. So big data analytics as a key enabling technology, it brings its power into the cyber security domain. The best practices in industry and government demonstrated when used in a proper way, the big data analytics will greatly enhance organization cybersecurity capability that is not feasible with the traditional security mechanisms. So it is a worth nothing that applying the big data analytics in cybersecurity domain is still in its fancy stage and facing some unique challenges that the many scientists from more traditional cybersecurity fields or other big data domains may not be aware of the following the challenges. And we are going to discuss how they affect the design and implementation of cybersecurity solutions using big data. And they can also be considered as potential future directions of big data analytics for this cybersecurity. If you see, there are like lack of unlabeled data, data quality, high complexity, dynamic environment, keeping up with the evolving technologies, operations, regulation, and the data encryption, disappropriate cost of false negatives, etc. So let us see, just have a quick glance on each one. The first lack of labeled data. I think most of you who have worked on machine learning, they'll understand the concept called as labeled or unlabeled data. So what is the challenge with this labeled data? That is, if you do not have enough labeled data, what are the problems? So the way the big data works is to learn from the data and tell the stories. However, the quantity of labeled data and the quality of normal data can both pose the big challenges to the security analytics. Both the quality as well as the quantity pose the big challenges to security analysts. The goal of doing the cybersecurity analytics is to detect attacks, breaches, and compromises. However, such incidents are usually scarce for individual organizations. Even though there are a few government and commercial platforms for organizations to share the intelligence about attacks and breaches, there is usually not enough details in the shared data. So except for a few very special problems, example for malware analysis, there is a very limited labeled data for cybersecurity. That means, like, suppose if you take one simple example like whether the mail is spam or not, if you're able to label the data, able the mail based on the text like spam or not, Then that with the help of a supervised machine learning, we could apply this to find out, to detect any new signatures. So in such a situation, the traditional supervised learning techniques are not applicable, right? If you do not have enough labeled data, because the supervised machine learning algorithms needs labeled data, and also that should be more. Okay, we cannot just simply pass the few records, few samples, labeled samples to train the model. So we need a significant amount of labeled data, so to train the model, so that the model will work more better. So the learning will rely heavily on a unsupervised learning and heuristics. So that is one challenge, lack of labeled data. Every day, the attackers are trying to trying the different approaches, and that's why it's about if you are using the antivirus software, you need to enable, if you have installed the antivirus software, but that is not being updated frequently, then it would not detect the new virus, new signatures. So that's why we have to enable that feature, so that it will download the new signatures from the vendor automatically, so that it would be able to detect the new signature, find the new viruses. So next one is the data quality is another big challenge. That is, among all the data available for cybersecurity analytics, an important type of data source is the alerts from various security tools such as IDS or IPS, firewalls, proxies. So unfortunately, such security alert data is usually saturated with false alerts and missing detections on real attacks. So new signatures and rules can also add significant hiccups to the alert system. So such situation, together with the false positive and negatives, should all be taken into consideration for analytics programs. Next one is the high complexity. That is, the complexity of large enterprise IT environments is usually extremely high. That is, a typical environment can involve hundreds of the physical zones, thousands of applications, tens of thousands of users, hundreds of thousands of servers and workstations, the various activities, accesses, connections. They're all happening among such a large collection of entities can be extremely complex. So because the security threats takes place all over, the properly modeling and reducing such a high dimensional problem is very difficult. And next one is a dynamic environment. So that is, the modern IT environments are highly dynamic and constantly changing. The models that work for one organization may not apply to another organization or the same organization 6 months later. So it is important to recognize this dynamic nature of IT's environment in the analytics projects and plan the plenty of flexibility in analytics solutions in advance. In keeping up with the evolving technologies. That is, big data is fast evolving technology field. So new improvements or groundbreaking technologies are being developed every week. So how to keep up with this technology evolution and make the correct decisions on technology adoptions can be $1 million question. So this requires the deep understanding of both technologies and business requirements. Next, operation. Analytics is only one of the functions of big data cybersecurity programs. Crucially, the program also needs to provide the data retention and data access for security analysts and investigators. Hence, there will be a lot of operational requirements in data availability, promptness, accuracy, query performance, workflow integration, access control, and even disaster recovery for the data platform, data management, and the analytics models. The seventh one is a privacy. The era of big data raises the concern on privacy to a new level. Now, by combining a vast number of data sources, analyst can gain unprecedented insight on user or a customer behaviors. So how to protect and control the exposure of user privacy while providing necessary information for security operations is not a trivial problem. That is called a privacy preserving mining or privacy preserving techniques. So data encryption, data masking, and the access control technologies need to be carefully designed. So that is mainly in the privacy preserving, we use masking and to hide the highly confidential information so that it will not be disclosed to the other users. So data encryption, data masking, access control technologies need to be carefully designed and integrated to achieve the proper protection according to the organization's requirements. Next, to regulation and the compliance. So big data also poses new challenges for organizations to meet regulation and compliance requirements. So the challenges are mostly on the classification and the protection of data becomes combining that is multiple data sources could reveal additional hidden information that may be subject to the higher classification. So because of this reason, in some highly regulated situations, it is difficult to apply big data analytics. Next, the data encryption. So we enjoy the benefit of having a lot of data and extracting useful information from it, but benefits come with responsibilities. Gathering and retaining data will impose the responsibility of protecting the data. So in many situations, data needs to be encrypted during the transfer and storage. So when the multiplied by the large volumes of big data, this can mean the significant performance and management overhead. The next one is disproportionate cost of the false negatives. So positive and false negatives. You need to understand the impact of both. So in traditional big data fields such as web advertising, the cost of false negatives is usually at an acceptable level and comparable to the cost of a false positive. For example, losing a potential buyer will not cause much impact to a company's profit. However, in cybersecurity, the cost of false negative is disproportionately high. So missing one attack will potentially lead to the catastrophic loss and damage. Okay, I think you would understand better. Then the intelligent adversaries, that is another unique challenge of cybersecurity analytics is that the subject of investigations are usually not static things. So big data cybersecurity deals with highly intelligent human opponents. So we will deliberately avoid detection and change the strategies if they are aware of detection. So it requires a cybersecurity analytics to quickly adapt to the new security threats in context and adequately adjust its goals and procedures as needed. So the big data, that is, if you look at the big data aspects and you understand what is the importance, what is the power of big data in cybersecurity. And we have discussed the introduction, we have discussed about the V's and the differences between the traditional analytics and big data analytics. That is another thing you need to keep in your mind. And the differences in terms of distributed storage, support for unstructured data, etc. And the fast processing, big data ecosystems. These are all the points we need to consider. And the infrastructure of big data ecosystem and what are the analytical applications and what are the visualization platforms, etc. And you would also need to understand, because to understand the need for big data analytics in cybersecurity, you need to understand the limitations of traditional security mechanisms so that will address easily. And also the evolving threat landscape requires the new security approaches. So we need to adapt the new technologies. And the big data also offers the new opportunities to the cybersecurities so that we could apply the big data analytics in cybersecurity. based on the category of solutions, because the solutions will be categorized different. So based on that, we could offer the solutions. So you need to understand the mainly big data analytics architecture, big data security analytics architecture, like what are the different, mainly five core components we discussed in this session, especially services or apps, data integration, data access, data storage, and data consumption, etc. And you need to study understand the different use cases, mainly to understand, to get more clarity of the concepts, and especially the last concept what we have discussed, the different challenges. There are different challenges, so you need to understand so that we could correlate. Then we apply the big data analytics for solving the security problems. So that's it from my side. It is over. Thank you for all for patiently listening. It's around 2 hours complete theory-oriented lecture. And if you have any queries, because to understand this session, you should have a knowledge like big data. What are the mainly the big data processing frameworks like Hadoop, Apache Spark, and other ecosystem components. And you would also need to understand the cyber security concepts. Then only you would. So I hope whatever I discussed is clear to all. And if you have any queries, sir, you're always welcome. So that's it from my side.
Participants, do you have any queries? You can go ahead now.
You can also text me in chat window if you want. Okay, all right. If you have no queries, no issue, you can also contact through my email if you have any queries further. I'm always ready to help you. Thank you all, and thank you once again. Yeah.
Participants, if you have no queries, we can wind up the session. Thank you, sir. Thank you for sharing the knowledgeable and informative session with us today. We look forward to the more sessions with you, sir.
Okay. Thank you. Thank you all. Have a nice day. Take care. Bye-bye.
Thank you, sir. Thank you, participants. Let's join in the afternoon session at 2 p.m. So attendance link and feedback link is in the chat box. You can go through it. So we'll meet in the afternoon session. Have a happy learning. Bye. Come on.